Hey guys, welcome back. Today we are starting a new unit on solutions, solubility, acids, and bases. Today we're getting started with acids and bases. We're going to learn how do we identify them, and then also we will be able to talk about pH, how pH associates with either acids or bases, and we'll go from there. All right, so a quick reminder, this is the pH scale. And you guys have probably seen the pH scale before because at this point you're in physical science or chemistry, and you've seen this before probably in biology. I know we talk about the pH scale a little bit in earth science when we talk about ocean acidification. So just a quick reminder of what pH is. pH stands for the potential of hydrogen, and this is the measure of hydrogen ions or hydrogen cations, right? Remember, this little plus symbol right here means he's positively charged. The concentration to show how acidic or basic a solution is, okay? So when we're taking a look at the pH scale here, 7 is going to be neutral. Okay, so if you're taking measurements of a pH and it turns out to be 7, that means it's neutral. Typically tap water, distilled water is a pH of 7. As you go to the left-hand side, so as your pH decreases, these are going to be your acids. So anything less than a 7 is an acid on the pH scale. And these are things like coffee, soda is very acidic, Coca-Cola, tomatoes, lemons, battery acid, very acidic. And then as we go to the right, so above a 7, anything above a 7 is basic. And these are things like bleach, ammonia, soap, etc. Okay, so 7 is neutral. Below a 7 is acidic. Above a 7 is basic. So what is an acid? An acid is a substance that contains hydrogen ions that ionize when dissolved in water. So they're the only molecules that ionize when they're dissolved in water, and they're electrolytes. And unlike other molecules like sugars and alcohols, the hydrogen leaves the molecule and bonds with the water molecules to form a hydronium ion, which is H3O+, right? So that's a cation again. So let's take a look at this reaction. So here we have our acid. So this would be hydrochloric acid. It's hydrogen and chlorine bonded. And when it dissolves into water, it will dissociate into that hydrogen cation and that chlorine anion. Okay, so H plus and Cl minus. So hydrogen is going to leave the acid and then bond with water to form that hydronium ion. Okay, so we have hydrogen and water. This is water, H2. There's two H's here, H2O. And this is your hydronium atom, or ion, excuse me. So what's happening here is that this hydrogen, as this acid is added to water, right, it associates with the water. It is ionizing. It's breaking down into the hydrogen cations, the chlorine anions, and this hydrogen here is going to bond with the water molecule to form the hydronium ion, okay? You can tell an acid because acids donate hydrogen, okay? So this was our hydrochloric acid. It donated its hydrogen, bonded with the water molecule, and gave us the hydronium ion, okay? So that's how we can tell that's an acid. Typically when you're looking for an acid, you're just looking for something that has a hydrogen in it. So this hydrochloric acid, this hydrogen is being donated. So here are the properties of acids we need to know. They typically are sour and sticky, so think of a lemon. They react with metals. They are electrolytes. They have a pH less than 7. Okay, so a pH less than 7 would let us know it's an acid. The lower the pH, the stronger the acid. Okay, so a pH of 1 or 2 would be a stronger acid than a pH of 4 or 5. So the lower the number, the stronger the acid. They donate hydrogen, and this increases hydrogen concentration or hydrogen ion concentration in a solution. Okay. So with hydrogen, or acids I should say, there are certain indicators we can use to let us know whether a substance is an acid or not. So there's something called litmus paper. It's an indicator test that you use. It's a little strip. You dip it into your solution, and then when you take it out, it changes color. So blue litmus paper will turn red in the presence of an acid. So you see here this initial color would be blue, and then you've dropped a little bit of the substance on it and it turns red. That would indicate that there's an acid. There's also an indicator called phenolphthalein. This would turn colorless in the presence of an acid. So you would start out with kind of this really pretty red-pink color, and then as you add acid to the solution, that color would eventually disappear. So if the pink turns to clear, that would let us know that there is an acid here. All right, so we've talked about acids. Now let's talk about bases. So bases tend to feel slippery. They hydrolyze fats and they make soaps. So soaps are basic. Also, bleach is basic. If you've ever cleaned with bleach before, and then you felt your hands kind of feel a little bit more slippery, that bleach is breaking down your skin barrier, and it's making it feel that way. So to make soap, animal fat is dissolved in alcohol, and sodium hydroxide or potassium hydroxide is added. So I want you guys to pay attention to these formulas here. So we have hydroxides, which are OHs. Anytime you see an OH, that's going to be a pretty good indicator that you're dealing with a base, okay? Because acids donate hydrogen and bases will accept hydrogen. And when we're dealing with bases, if they have a hydroxide, so that OH, you can typically tell from the formula that it's going to be a base. So drain cleaners, usually sodium hydroxide, will react with grease that's clogging the drain and form soap, which can then wash down the drain. So they're on the opposite end of the pH scale. Okay, so here are our properties of bases. Typically, they're bitter and slippery. They will react with fats and oils. They're also an electrolyte. They have a pH greater than 7. They are a proton acceptor, so they will accept the hydrogen. And it will increase the hydroxide concentration, so that OH anion will increase with the base. Another thing to know is that bases will neutralize acids. So neutralization, and we'll talk a little bit more about neutralization tomorrow, but that's a double replacement reaction that involves the reaction between bases and acids. So the hydrogen cation of the acid will combine with the hydroxide anion of the base to form water. Okay? The cation of the base will then react with the anion of the acid to also form a salt. And like I said, we're going to talk about this a little bit more in tomorrow's lesson. But what we need to know is that bases will neutralize an acid. So for example, if you have heartburn, so if your stomach acid's coming up, giving you some issues, milk of magnesia, Tums, those things are bases that when you take it, it will neutralize that acid. So they just basically what it does is that it will raise the pH up and it will bring the pH to a neutral level. Okay, so if you wanted to neutralize an acid, how you would do that is you would add a base. That's basically what you need to know. Okay, and let's take a look at these indicators. So for bases, red litmus paper will turn blue in the presence of a base. So again, we're starting with this red litmus paper. It's this red color. Drop a little bit of the solution or dip it into the solution. If it turns blue, that's going to be an indication that a base is present. Now phenolphthalein will do the opposite. So remember before with the acid, if we started with the pink phenolphthalein and we added an acid to it, it would disappear. Here, if you add phenolphthalein to a base, it will turn bright pink in the presence of a base. So if you add phenolphthalein to a solution and it turns pink, that's going to be our indication that there's a base. And that's it for today. Okay, so basically what we need to know is that acids are a pH less than 7. The lower the number, the more strong the acid. And we need to know that acids are hydrogen cation donators, right? So they will donate the hydrogen cations. And with acids, you have an increased concentration of hydrogen ions. For bases, you have an increase in the hydroxide anion, so that OH minus. Bases are a number higher than 7 because 7 is neutral. And the higher the number, the more strong the base. Okay, so lower number, stronger acid. higher number, stronger base. Okay, so today was just the basics, identifying acids, getting the definitions. You guys will have an assignment where you will read a little bit more about acids and bases and answer those questions, but these are the ends of your notes today. If you have any questions, let me know, and if not, you guys are good to move on to your assignment.